Now I will read the question. During the forward stroke of the piston of a double acting steam engine, okay, so just keep it in mind, double acting steam engine. Per cycle you have two power strokes. So that is the meaning of double acting steam engine. So if you just read this and see the graph, one power stroke, second power stroke within one revolution. So that is symbolically you have to understand. So double acting steam engine. Okay. The turning moment has a maximum value of 2000 kilonewton Newton meter. So which means what? Which is the maximum in this graph? Peak. This is the maximum. Okay, definitely this is taller than this, right? So therefore this is 2000. 2000 Newton meter when the crank makes an angle of 80 degree. So the peak occurs at 80 degree of crank angle. So this is 80 degree, which is 4 pi by 9. Okay, 80 if you solve, you will find out that this 4 pi by 9. Okay, 80 degree with the inner dead center. During the backward stroke, the maximum turning moment is 1500 Newton meter. So during the backward stroke, this is peak is 1500 Newton meter. When the crank makes an angle 80 degree, the outer dead center. So therefore 80 degree from this side. Clear? 80 degree from this side. So 80 degree, previously 80 degree from this side. So now 80 degree from this side. So which is 360 minus 80, somewhere around that. Okay. Now with the outer dead center. The turning moment diagram for the engine may be assumed for simplicity to be represented by two triangles. So the crank makes 100 rpm and the radius of gyration of the flywheel is 1.75 meter. Find the coefficient of fluctuation of energy and mass of the flywheel to keep the speed within plus or minus 0.75 percentage. 0.75 percentage. Here, CS is given to you. You are going to find out delta E and use the delta E in the same formula like the previous problem. Find out M. Here M is the unknown quantity. What did you do in the previous problem? You found out delta E from the graph and used it to find out CS. Mass was given in the question. Here the same thing. Delta E you are going to find out from the graph. Here mass is unknown, CS is known. Same formula, same everything steps. Only unknown is going to vary. Okay, fluctuate mass of the flywheel to keep the speed within plus or minus 0.7 percentage of the mean speed. Also determine the crank angle at which the speed has its maximum and minimum values. This question we will take care later. Which is the crank question where you have maximum and minimum speed of the flywheel. That we will look into separately. I will come back to the question and explain you what is that. Now list down the given data. So n is 100 rpm. Omega from that you find out 2 pi n by 60. Radius of there is 1.75 meter. Coefficient of fluctuation of speed CS is given as plus or minus 0.75 percentage. Okay. So omega 1 minus omega 2 is 1.5 times of percentage of omega. So that is the meaning of this. Plus or minus 0.75, which is totally 1.5. Okay. So difference between minimum and maximum speed will be 1.5 times the speed. So that is the meaning, plus or minus 0.75. Where your mean speed is at the middle, 0.75 to the left, 0.75 to the right, above and below. So coefficient of fluctuation of speed is omega 1. This is the general formula for coefficient of fluctuation of speed. Okay. The general formula for coefficient of fluctuation of speed is omega 1 minus omega 2 by omega. So I have presumably written that 1.5 percentage of omega is the variation. Okay. So this is 0.0015 omega divided by omega. That is 1.5, 0.0015. So what is 1.5 percentage of omega? What is this? This can be written mathematically. When you are doing calculation, percentage should not be written as percentage. 0.0015 divided by 100. Times of omega divided by omega. So I can cancel this. What is that? CS. CS equal to 0.0015. 1.5 percentage is multiply not 0.15, not 1. Okay, that is 1.5 percentage. Divided by 100, you write. CS is 0.015. Clear? Now I am moving on. So coefficient of fluctuation of energy first I have to find out. Then only I can find out the coefficient of fluctuation of using that I can find out the mass of the flywheel. Delta E I am going to first find out. As I told you earlier, okay. So above the mean torque line, the largest area is delta E. If you have multiple area, you should not add it. That is not delta E. Okay. Many fluctuations are occurring in every cycle. In that which is the largest fluctuation is called as delta E. It is not the summation. Okay, so therefore, definitely this is your delta E. Clear? So don't tell me that there are two things why I should not find this, because certainly this seems larger, right? So largest is the delta E. What is the maximum fluctuation of energy? So that is delta E. Okay, the name itself tells you maximum fluctuation of energy. Delta E. Coefficient of fluctuation of energy CE. Don't worry about that. I will tell you when we are coming there. Now first let us find out delta E. Turning moment diagram for the engine during the forward and backward stroke is shown above. Okay, the points O represent the IDC and G represent the ODC, outer dead center. Okay, where is O and where is G? See here, this is the inner dead center, this is the outer dead center. Again, it comes back to the inner dead center, completion of the cycle. So S is nothing but O, same points. Clear? So that is the graph. We know that the maximum turning moment and the crank makes an angle 80 degree. Convert the 80 degree to radians. 80 into pi by 180, you will get 4 pi by 9. Very simple. 80 into pi by 180. So cancel 80 with 180 in some 10 tables or something, you will get 4 pi by 9. Okay. So don't do calculations with degrees. Calculation should be done only with radians. The maximum turning moment and the return stroke is 80 degree from the ODC. So therefore, what you have to do 80 degree from the ODC is either 360 minus 80 or 180 plus 80. Okay, from ODC means ODC angle is 180. From that you add 80 degree. Clear? So this is your, as earlier we have told, this is your outer dead center. From here another 80 degree. So this is 180 degree point. Okay, so plus 180 is 260. So now convert 260 into radians. 260 into pi by 180. So it comes around 13 pi by 9. Clear? Okay. So A, B, the height, this maximum peak torque is 2000. That was mentioned in the question. It was given already. Clear? LM is 1500. Height of this triangle, LM. So T mean equal to EBQM, mean resisting torque. So I don't know the value. It is not given in the question. So some point, this line is called as the mean torque line, but I don't know the height of this line. I am yet to find out what is this value. You are going to find out yet. Hereafter only you are finding it out. So we know that the work done per cycle equal to area of the triangle, the entire, not just the shaded triangle. The two large triangles, if you find the area and add, you will get the entire work done. OAG, this whole triangle, what you did in last problem, the whole area you have found out. Similarly, in this problem, two triangle, full triangle areas you find out and add, you will get the work done per cycle, which is equal to mean torque into angle turned. Okay. The same way, I'm going to find out the area of these two large triangles. Okay. So half into base into height. Let us look at the first triangle. What is the base? This is pi radians, correct? It is marked here. Half of the revolution from TDC to, I mean, inner dead center to outer dead center, one full reciprocation of the distance from left to right. So definitely it is 180 degree of crank rotation. Similarly, from here to here, bottom dead center or outer dead center to inner dead center, this is one right to left motion, which is pi to 2 pi. So definitely this is pi, this is pi. Don't write 2 pi for this here. Okay, it is also pi. From here to here, what is the span? This is pi. Again, this is pi. Okay, so therefore you have to put pi only here, not 2 pi. Substitute the values. What is the height? This height is 2000. This height is 1500. It is very easy to calculate the area of two triangles. Required data is there, half into pi into 2000, half into pi into 1500. This pi only I was telling, don't write 2 pi here. This, for this triangle alone, what is the length? Pi only. This number may be 2 pi, but what is this length? Pi only. Okay, so therefore pi here. Half into base into height, half into base into height. Two triangles, you sum up the areas, you will get 1750 pi Newton meter, or you can multiply the 3.14, you will get one answer. 1750 pi Newton meter. Okay, work done per cycle is 1750. Keep it as equation 1. Okay, we also know that work done per cycle equal to mean torque into angle turned. Here total angle turned per cycle is 2 pi. So I am writing 2 pi here. Last problem it was 6 pi. Here only 2 pi. So T mean into 2 pi. See equation 2. Equate equation 1 and 2. T mean into 2 pi equal to 1750 pi. Pi gets cancelled. So mean torque equal to 1750 by 2. So which is 875 Newton meter. So mean torque I have found out. So the height of this mean torque is 875. This is 875. Okay. Right. So maximum fluctuation of energy equal to area of the triangle ACD. This small triangle, the largest of the shaded triangles. This triangle, if you find out the area of this triangle, then you can find out the delta E. So for that I have one problem. Now I have found out T mean. So therefore this height can be easily found out. Now we have to apply similar triangle principles and find out the base width of this triangle. Then you can find out the half into base into height. Okay. So from similar triangles ACD and AOG. So which is ACD? ACD is the smaller triangle. ACD and AOG, full triangle. Okay. From similar triangles, what is the ratio I am writing? CD by AE. CD base length and CD by AE equal to OG by AB. OG by entire height AB. So it is not that you have to write only in this manner. It can also be written like this: CD by OG equal to this. This is not the only way to write this. So how did we write last problem? Base by base. CD by OG equal to height by height. AE by height AB. If you do this also, you will get the same answer. It can be written in any manner. I want to find out the unknown value. Okay, that is the beauty in similar triangles. You can write it anywhere. It is not that you have to write only base to base, height to height. This here, what I am writing? I am writing CD by AE equal to OG by AB whole height. So that please understand what is written here. Don't by heart this alphabets. It is meaningless. So base of the small triangle divided by height of the small triangle, one ratio you will get. That should be equal to base of the large triangle divided by height of the large triangle. This can also be done like what you did last time. Base of the small triangle divided by base of the large triangle equal to height of the small triangle divided by height of the large triangle. That is also correct. Both you try both ways, you will get the same answer. You try it in your notebook. Okay. So therefore CD equal to AE into OG by OB, cross multiply. Only unknown thing here is the this base length. I don't know. This is what I am trying to find out. Keep that on the left side. All other things you bring to right side. Okay. So AE, this height. So mean torque is 875. This is 2000. Subtract it. So 2000 minus 875. AE. So that is 1125. Okay. So next thing, OG. What is OG? O to G. This is 2 pi. I know. Similarly, the entire height is 2000. That is also known. Now you know all the numbers to put in here. So substitute all the values. So 1125 into pi by 2000. Okay. So that comes around 1.764 radians, which is the base width of the smaller triangle. Now find out the area of the small triangle. Half into CD into AE. Half into base into height. This triangle area, how will you find out? Half into base into height. Okay, so this base is not, just now I have found out as 1.764 radians using the similar triangle principles. Okay, height is known. 2000 minus 875. Sorry, 875. 2000 minus 875, 1125. This height. This is your mean torque. Mean torque you already know. Peak is 2000. Subtract mean torque from the 2000, you will get this height. The base you have found out now. So therefore you calculate the area. So half into 1.764 into 1125. So that comes around 992 Newton meter. So this is the maximum fluctuation of energy. Okay. Maximum fluctuation of energy is 992 Newton meter. But question, what is the question? Coefficient of fluctuation of energy. Maximum fluctuation of energy is not asked. Okay. With this I am going to, the coefficient of fluctuation of energy equal to delta E divided by work done per cycle. This formula you have to remember. This was initially when I was telling you what is a turning moment diagram. At that time in the evening class I told you this formula. No problem if you don't remember. Write this down. CE equal to delta E. Maximum fluctuation of energy is nothing but delta E. Okay, delta E divided by work done per cycle. So there you will get the maximum coefficient of fluctuation of energy. Okay, so 992 divided by work done per cycle is 1755. This you have found out the entire area of the two triangles you have summed up. Okay, so that is the work done per cycle. Two triangle areas you have summed up.
Sir, good morning, sir. Sada, sir.
Sir, good morning, sir. Sir, good morning.
Sada, sir.
Sir, tell me, sir.
Hello,
sir.
Good
morning. Good morning. Solunga, sir.
So 2 minutes, sir. Just I will read out the absentees of yesterday's evening class.
Sir, can we do this after some time, sir?
When you will be completing, sir?
Sir, maybe another. Okay, you can take the last 5 minutes, sir.
Okay, sir. No issue.
Okay.
Just you remind me, sir.
Sure, sir. Okay. So coefficient of fluctuation of energy is delta E divided by the summation of this area of the full triangles. First you did half into base into height, full triangles you have added, and that you equated to T mean into theta. That full area. Okay, that is the work done per cycle. Okay, so delta E by 1755, it comes around 18 percentage, 0.18. So that is the coefficient of fluctuation of energy. Okay, so next, mass of the flywheel. This is the second question, mass of the flywheel. So delta E equal to same formula which you used in the last problem, m k square omega square cs. Okay, so delta E just now you found out n 992, k square, k is 1.75 meter, coefficient omega is 10.47, cs coefficient of fluctuation of speed is given in the question itself, 1.5 percentage, 0.015. The only thing unknown here is mass. Okay, so substitute all the numbers. So delta E is 992, mass is unknown, keep it as m. Okay, so k 1.75 square, radius of gyration, omega is 10.47 square, cs is 1.5 percentage, 0.015. So solve for m, 197.2 kilogram. So that is the mass. Okay, so second question is over. Now let us go back to the question and read now the third question. You have to understand that very, very carefully. The third question. So read the third question. If the crank takes 100 RPM represented by the diagram, where is the third question? Also determine the crank angle at which the speed has its maximum minimum values. Speed means here the speed of the flywheel. Okay, so effective speed of the flywheel is the speed of the engine in turn. Okay, so when will the speed of the flywheel be maximum and minimum? Okay, so that you have to think intuitively from the diagram. You can understand that. Okay, I will tell you how to predict the maximum and minimum speed point using the graph. Okay. So crank angle for the maximum and minimum speeds. Speed of the flywheel is minimum at point C and maximum at point D. Okay, how I am concluding this? That you have to understand very carefully. Let us think about this. If you look into this is the mean torque line. Okay, there are only two places where you have more energy than mean torque. These two are the places. So from this theta to this theta and from this theta to this theta, you have more energy than mean torque line. So maximum speed point will be somewhere here, correct? Within these two angular spans. It is only feasible. So therefore, what I am telling you is now this much chunk of energy is added to the system at this point. So when on reaching this point, you after this angle, you are getting this much of energy added to your system. So therefore, this is supposed to be the least energy point, correct? So it comes to the minimum point, and there I have a power stroke, I have this much of energy added. So this point is assumed to be the minimum energy point and minimum speed point, point C. Because after point C, I am getting this much of energy added. So this is supposed to be the minimum energy point. Similarly, maximum energy is added here. So at this point is assumed to be the maximum speed point with respect to the flywheel. So in these type of area problems, take the largest delta E triangle or whatever may be the shape. Starting point of that will be the minimum energy point. End point of that will be the maximum energy point. Clear? So that is how I take this. Here also the speed will, this will be a small, speed will be less, speed will be very high here, but the magnitude will be lesser compared to this. Okay, so therefore point C is taken as minimum energy point, minimum speed point of the flywheel, maximum speed point of the flywheel. Why this is maximum? Because this much energy is just added to the system, and at the end of energy addition, you will have highest amount of acceleration. So that is the concept with which I conclude C and D are the 2 points, minimum and maximum speeds. Okay, so let theta C and theta D be the crank angles from IDC for maximum and minimum. That is nothing but here I have written theta C, minimum point, maximum point angles I am taking, theta C, theta D. Okay, just I am naming the points. So from similar triangles ACE and AOB, similar triangles ACE, where is E? ACE is small triangle. Half of this triangle ACE and AOB, half of the right angle triangle I am taking. Okay, from these two similar triangles, just look at the left side of this line. So this shaded portion is taken as one triangle and the larger triangle is taken again. This half of this large triangle is taken as a right angle triangle, and in that I am applying the similar triangle principles. Okay, so CE by OB equal to CE base length comparison. Okay, base length CE by OB equal to AE by AB, AE by entire height AB. So from that I am going to find out CE, half of this angle. I don't exactly know whether this peak is at the middle. If we know that this is exactly symmetrical, this shaded portion is exactly symmetrical. I know this angular span. Okay, if I know this is exactly a symmetrical isosceles triangle, then I can put half of that is half of this, which you have already found out. Half of that is this length, but we don't know whether this is a symmetrical triangle. Therefore, you are again applying similar triangles and finding out this length. Clear? You cannot say that CD by 2 is CE. That assurance is not there in the question. Therefore, you are again applying similar triangles, half of the triangle, and finding out the length of the CE line, base length. This you are finding out by similar triangle principle. So this by this equal to this by this entire length, and you are finding out this out of the relationship. So put all the numbers. So AE is 1125. AB is 2000, OB is 4 pi by 9. How OB is 4 pi by 9? Because it is already given in the question 80 degree, this span. The peak occurs at 80 degree. So 80 degree I have converted to radians already. Previously in given data itself it is there. Okay. So peak occurs at 80 degree from the inner dead center position. So this is 80 degree. 80 is nothing but 80 into pi by 180 is 4 pi by 9. That is how I got this 4 pi by 9. Okay. So multiply that, you will get the answer to be pi by 4 radians. Which is pi by 4? Theta C is pi by 4. Okay. So minimum speed point of the flywheel. Similarly, maximum speed point of the flywheel, here I am going to find out. For that, what I am going to do next? So theta C is, so convert this pi by 4, pi by 4, so CE is pi by 4, the span is pi by 4. Okay, this length is pi by 4. So to find out the value of this, what I am going to do? See, the length of this line is pi by 4 radians. Therefore, I know this value is 80 and the length is to be pi by 4. So now what I am going to do? I am going to subtract pi by 4 from 4 pi by 9 to identify this angle. Are you understanding? I know, see, this from starting point, this line is 4 pi by 9. From here, I know there is another line which is pi by 4. This is pi by 4. Okay. This is 4 pi by 9, entire length. I want to find out this. So what you do? Subtract pi by 4 from 4 pi by 9. Therefore, you will get this. Okay. Your answer is not pi by 4. Are you understanding? I think with this line example, you can understand. You know the entire length of 4 pi by 9. Okay. From this line, I know this is pi by 4. So I want this. Therefore, subtract from 4 pi by 9. You subtract this pi by 4, you will get this number. So 4 pi by 9 minus pi by 4 is 7 pi by 36. Convert that 35 degree. So this minimum speed point occurs at 35 degree from inner dead center. Clear? Similarly, the other point, D point, I am going to find out from similar triangles AED. The mirror reverse of this, same thing. You know this is 80 degree. Take this similar triangle. Take this small similar triangle. You have to equate that and find out the value of this base. Now you add to 80. Then you will get this point. Are you understanding clearly what you did earlier? From 80 you subtracted and found out this. Now from 80 you add this, you will get this. Okay, so it's very simple. So now use the similar triangle principle. You are going to find out ED. ED is what? This line. ED is this line. Okay. So that comes around 2.8 pi by 9. See, it is not symmetric. Earlier you got pi by 4 left side. C to E. E to D is 2.8 pi by 9. It is not a symmetric triangle. Okay. 2.8 pi by 9. So that I am going to add to 4 pi by 9, 80 degree. So I am getting 6.8 pi by 9, which is 136 degree. So that completes the problem. 992 is the delta E, maximum fluctuation of energy. Coefficient of fluctuation of energy 18%. Mass of the flywheel 197.2 kilogram. and the maximum velocity point is 35 degree, minimum velocity point is 136 degree. So that completes the problem. Session is open for questions. 2 minutes. 2 to 3 minutes. I'll give you time for asking any questions in this problem. Any doubts? This is your example 16.7 in Kurmi.